There's a place on the border of Venezuela, Brazil, and Guyana where the jungle stops and a wall of rock begins. Not a slope, not a hillside. A wall, almost perfectly vertical. 400 meters straight up, then nothing. A flat plateau stretching across 31 square kilometers, like something sliced clean with a blade. The indigenous Payman people have lived in the shadow of this thing for thousands of years. They call it Roraima, and their tradition says it is not a mountain at all. It is a stump, the stump of a sacred tree so enormous it once held all the fruits and vegetables in the world, cut down by a trickster god named Macunaíma, whose axe blow sent the trunk crashing down and unleashed a flood across the entire earth. Geologists have a different name for it. They call it a Tapouis. They say it formed through 2 billion years of erosion. They are correct. And here's the thing nobody tells you. Both stories are saying the same thing. Something enormous was here. It was cut. What remains is the stump. Every table mountain on Earth is a monument to destruction. The flat top is not what was built. The flat top is what survived after everything else was taken away. That is the story this video is going to tell you. The story of the giants that were erased and the stumps we walk past every single day calling them mountains. If you value documented geological history and the true stories behind the landscapes we think we know, subscribe. It is the best way to support this work. And drop a comment telling us what city you're watching from. We are genuinely curious where in the world this is landing. This script is researched and factual, drawing on the United States Geological Survey's National Geologic Map Database, specifically the 2020 Colorado Geological Survey Open File Report of 19-08 on the Grand Mesa Quadrangle by Chestnut, Wegman, and colleagues, a peer-reviewed geological mapping publication that examines exactly the rock layers and erosion mechanics that created these formations. The second source is the peer-reviewed chapter published in ResearchGate titled The Guana Shield, authored by Nathan Lugin and Jonathan Armbruster, which documents the 2 billion-year geological and biological evolution of the ancient craton beneath the Tapouis. Both sources are the kind that geologists cite in academic papers, not the kind that show up in travel blogs. Now back to the information. The word mesa means table in Spanish. The early Spanish explorers who crossed the American Southwest in the 1500s gave flat-topped mountains that name because that is exactly what they looked like. Furniture abandoned in the desert. Enormous, isolated with vertical cliff walls and a perfectly flat surface on top. The Navajo had lived among them in the Four Corners region, the border area of Arizona, Utah, Colorado, and New Mexico, for generations already. Monument Valley alone, you know those images. The red towers rising from the orange desert floor in every Western movie ever filmed. John Ford shot 7 films there. Those formations are buttes and mesas of the Colorado Plateau, eroding at a rate of 500 vertical feet every 1 million years according to the National Park Service. The plateau is being consumed. What you see today is the remnant of something that once covered all of it. Here's how a table mountain works. You start with a thick, flat layer of sedimentary rock stacked horizontally. Think of it like a massive layered cake covering hundreds of square miles. Different layers have different hardness. The soft ones, shale, mudstone, siltstone, erode fast when water and wind get into them. The hard ones, basalt, quartzite, sandstone, resist. When water cuts down through the landscape from rivers and rainfall, it attacks the soft rock first. The soft rock dissolves and washes away. The hard rock stays, and if you have a hard layer on top protecting everything below it, that section survives, while everything around it disappears into valley floors. What remains standing is called a mesa, a fortress of rock surrounded by the absence of the rock that used to be there. Every table mountain you have ever seen is a cemetery for its own surroundings. The valleys around it are where the mountain used to be. The Grand Mesa in western Colorado is the largest flat-topped mountain in the world. 500 square miles of surface, 40 miles across. It rises 6,000 feet above the Grand Valley and stands at 11,000 feet above sea level. Above 11,000 feet, it has over 300 lakes on its summit. The United States Geological Survey and the Colorado Geological Survey have both confirmed its formation in peer-reviewed publications. Andres Aslin, professor of geology at Colorado Mesa University, described in a published 2024 interview that the Grand Mesa is what geologists call topographic inversion. 10 million years ago, during the Miocene epoch, it was not a mountain, it was a valley. The ancestral Colorado River ran through it, and a volcanic field erupted from a vent near the area now called Crag Crest, sending at least 27 separate lava flows pouring into that river valley. The basalt cooled and hardened into a layer up to 310 feet thick. Then the Colorado and Gunnison rivers kept cutting downward into the softer sedimentary rock around it. They eroded the shale and sandstone at a rate of about 140 meters per million years according to the Colorado Geological Survey. And what was once the lowest point became the highest point. A valley became a mountain. The river floor became the summit. Right now, if you dig just below the basalt cliffs on the western edge of Grand Mesa, you find rounded river cobbles, the gravel of the ancient riverbed, sitting at the top of the highest mountain in the region. That is not a metaphor, that is the actual rock record. The bottom is now the top, the valley is now the peak. Table Mountain in Cape Town, South Africa, has been standing since at least 560 million years ago. The Malmesbury Shale at its base goes back to that period, the Cambrian, when this region was a shallow sea on the edge of a supercontinent. Over the next 170 million years, layers of sand and mud accumulated on that seabed, compressed into what is now called the Peninsula Formation sandstone, formerly the Cape Supergroup. This is the hardest quartzitic sandstone on the continent. Between 280 and 235 million years ago, during the formation of the supercontinent Pangaea, continental collisions folded and crumpled those sedimentary layers into a vast mountain range, the Cape Fold Belt. Table Mountain, the one you see today, is not the top of that ancient mountain range. It is actually what geologists call a syncline mountain. The flat top was once the bottom of a valley inside that fold. The anticline, the actual peak, eroded away entirely. What you see standing over Cape Town today is the valley floor of a mountain range that no longer exists. The surrounding rock that once towered above it is gone. Table Mountain endured because of the quartzitic hardness of the sandstone, and because the pressure from the tectonic collision forced the granite beneath it downward rather than folding it, an effect called isostasy, which later slowly pushed the formation upward as the mantle rebounded. The plateau is roughly 3 kilometers wide. It is one of the 7 natural wonders of the world, and it is a leftover, a remnant, the highest point of something that used to be lower. The Pemon people of Venezuela have lived alongside the Tapouis, the Table Mountains of the Guana Shield, for a recorded span of centuries. Their word Tapouis means house of the gods in the Pemon language. There are 115 of them in the Gran Sabana region of southeastern Venezuela alone. They range in height from 1,000 to 3,000 meters. Their total combined surface area is approximately 5,000 square kilometers. The Guana Shield beneath them is one of the oldest exposed portions of the Earth's continental crust. 1.7 billion years old Precambrian, assembled before multicellular life existed. The Tapouis are the remnants of a continuous sandstone plateau that once covered this entire shield from the northern border of the Amazon basin to the Orinoco, from the Atlantic coast to the Rio Negro. That plateau has been eroding for hundreds of millions of years. What is left are the isolated towers and tables, each one a fragment of a landscape that covered the continent. Mount Roraima is the highest of these Tapouis, at 2,810 meters. Its summit covers 31 square kilometers of exposed quartzite sandstone, a pseudokarst surface etched by rainfall. Its cliffs rise between 400 and 1,000 meters on every side. When Sir Walter Raleigh described it in 1595, during his search for El Dorado, he called it a crystal mountain gushing countless waterfalls. German scientist Robert Schomburg reached its vicinity in 1838, funded by the Royal Geographical Society, and reported the peak inaccessible due to its vertical walls. It was not climbed until December 1884, when Sir Everard M. Thurn found a ramp on the Venezuelan side and walked to the top. That same ramp is the only non-technical route up today. The summit hosts carnivorous plants and endemic species found nowhere else on Earth. It inspired Arthur Conan Doyle's 1912 novel, The Lost World. It sits at the exact triple border of 3 countries, and the Pemon said it was a stump before any European geologist arrived to agree with them, felled by the trickster Macunaíma. Tree crashes, flood follows, stump remains. Their creation narrative and the geological record align more closely than most people realize. The sandstone of Roraima dates to the Roraima Group sedimentary deposits, 1.8 to 1.4 billion years old according to the Guana Shield geological literature. The surrounding terrain has been eroding away for hundreds of millions of years. What is standing is what could not be taken down. The people watching the erosion over hundreds of generations described it as a cut, dead, still, standing. If you value documented geological and indigenous history like this, real facts, real sources, no filler, subscribe. It is the best way to support this work. And comment below, what city are you watching from right now? We read every single one. This script is built from sources like the Colorado Geological Survey's peer-reviewed open file report of 1908, published in 2020 by Chestnut, Wegman and colleagues, and the academic chapter, The Guana Shield by Lujan and Armbruster, the kind of primary geological literature that most channels never bother to open. Now back to the information. The same process plays out in Australia. In the Cockburn Range of northwestern Australia, flat-top mountains called jump-ups and tabletop hills rise from red desert plains, with cap areas as large as 350 square kilometers in some cases, according to the Wikipedia entry on Mesa Geology, which cites the same geological distinction: resistant caprock on top softer material eroding below. The Aboriginal Australians, who have lived around Uluru, officially a butte, the remnant of a once larger mesa, for at least 10,000 years consider it a sacred site connected to the Chukurpa, the law of creation. The geological name for what Uluru is, an Inselberg, an isolated rock outcrop left behind after its surroundings eroded flat, standing alone in a plain that used to be at the same level as its peak. The Sarisariñama Tapouis in Venezuela has something even harder to explain. On its flat summit are circular sinkholes 300 meters across and 300 meters deep. Perfectly circular holes drilled straight down from the plateau top into the rock, with their own enclosed ecosystems at the bottom. Species of plants and animals that live inside the sinkhole and nowhere else on the planet. The largest of these sinkholes is 300 meters in diameter and 300 meters deep. They form when underground rivers carve tunnels through the sandstone and the roofs collapse. But the result is a flat-topped mountain with holes through it, holes that are themselves 300 meters deep and contain a life that has been evolving in isolation inside a mountain for an unknown number of thousands of years. The BBC Lost Land of the Jaguar team explored one in 2008. They found an endemic species of frog and mouse on a single summit. Footprints of an unidentified mammal. The Tapouis are not relics. They are living laboratories of isolation, and what makes them laboratories is exactly the same thing that makes them look like stumps. The flat top, the vertical wall, the boundary between what survived and what did not. Now look at what these formations share. Table Mountain, valley floor of a destroyed mountain range. Grand Mesa, riverbed of a vanished valley. Mount Roraima, remnant of a continent-scale plateau worn to fragments. Uluru, lone survivor of a former mesa that eroded flat around it. Sarisariñama, summit with open holes to its own interior. Every single one of them is a survivor. The context they once existed in is gone. The rock that surrounded them, that was above them, that was at the same level as them, that rock is now sediment at the bottom of a river or a dust layer in the plains. What you call a mountain is what could not be destroyed. The destruction is the landscape. This is why indigenous traditions across every continent with table mountains describe them as stumps, as cut things, as the remains of something larger that fell. The Payman with Roraima, the Ute in Colorado, who considered the Grand Mesa a sacred and magical area. The Aboriginal Australians at Uluru, the Lakota near Devil's Tower in Wyoming, which the rangers themselves call a volcanic plug and whose fallen columns they call logs. These traditions did not have the vocabulary of stratigraphy or differential erosion, but they had 10,000 years of watching the landscape and understanding that what stands is what remains after something larger was cut away. The geological process and the traditional description are the same event from two different observational timescales. The Colorado Plateau is eroding at 500 vertical feet per million years. At that rate, in 50 million years, the remaining mesas of Monument Valley will be level with the desert floor around them. The Table Mountains of Venezuela will erode for another 100 million years before they flatten entirely. The Cape Fold Belt will continue shrinking as the quartzite gives way to weathering grain by grain. Every flat-topped mountain you have ever seen is in the middle of its own disappearance. It will not always be there. The stumps are going, slowly, without announcement. The next plateau, losing its rim today, will not make the news until a hiker falls from an edge that moved 2 centimeters over 2,000 years. By then, it will be too late to look at what was lost. In 2020, the West Salt Creek landslide on the southern slope of Grand Mesa moved 38 million cubic yards of material, 2.8 miles down the hillside in a single event. The largest landslide in Colorado history, according to reporting from the Colorado Public Radio and confirmed in geological monitoring records. It was triggered by heavy rainfall saturating fractured rock in the underlying Eocene shale layers. The same soft material in the basalt cap was slowly losing to erosion on every edge. 38 million cubic yards, moved in one day. The mesa got smaller on the south side by a measurable amount, not by millions of years of gradual wearing. By one rainstorm and one catastrophic failure of the soft rock below the hard cap. That is how it actually happens. Not slowly every day, and then all at once. The Pemon said, Macunaíma felled the tree crashed down, the flood came, the stump remained. Geologists would say an ancient sandstone plateau was uplifted, fractured, and then relentlessly eroded by rainfall and rivers over hundreds of millions of years, leaving isolated remnants called Tapouis at the triple border of Venezuela, Brazil, and Guyana, the oldest exposed rocks in the Western Hemisphere, dated to 1.8 billion years before the present, surviving because their quartzite was too hard to dissolve, and the rainfall keeps carving everything softer around them further downslope. The stump remained. And in 2020, at the bottom of the Grand Mesa in western Colorado, a geologist from Colorado Mesa University found rounded river cobbles sitting in the sediment just below the basalt cliff face on the western rim. Ancient gravel from the bed of the original Colorado River that flowed through the valley 10 million years ago, before 27 lava flows filled it, before the rivers cut 6,000 feet deeper, before the valley became the highest mountain in the region. The river that made the valley was buried under the mountain that replaced it. The lowest point became the highest. The valley became the peak, and the cobbles sat there in the rock, unchanged, still perfectly round from 10 million years of rolling in a river that no longer exists, waiting for someone to dig them up and read what they said. It said, something enormous was here. It was taken. What you're standing on is what could not be moved.